Welcome back. Lesson 16, The Basics of Counting. Introduction. Combinatorics is the study of arrangement of objects. It is an important part of mathematics. Enumeration, which is the counting of objects with certain properties, is an important part of combinatorics. Counting problems arise throughout mathematics and computer science. Basic counting principles. The product rule. Suppose that a procedure can be broken down into a sequence of two tasks. If there are n1 ways to do the first task, and for each of these ways there are n2 ways to do the second task, then there are n1 times n2 ways to do the entire procedure. For example, example 1, two friends rent a floor with 10 rooms. In how many ways can they assign separate offices for themselves? So notice they are looking for separate offices. The first friend has 10 options because there are 10 rooms. Once the first friend has chosen a room, second friend has 9 options. So in all, 10 times 9, 90 options. Okay, there are 90 ways the two friends can get separate offices. Here is second example. All the chairs in an auditorium need to be labeled. Each label consists of a letter in a capital case followed by a number from 1 to 100. How many such labels are possible? Well, there are 26 letters in our English alphabet. There are 100 numbers to choose from. So, each label is a letter followed by a number. 26 letters, 100 numbers. In all, 26 times 100, 2600. So that is 2600 different labels are possible. An extended version of the product rule is often useful. Suppose that a procedure is carried out by performing the tasks T1 followed by T2 followed by all the way till Tm. If each task Ti can be done in ni different ways, then there are n1 times n2 all the way until nm ways to carry out the procedure. For example, a meal in a restaurant consists of an appetizer, followed by a main course, followed by a dessert, and a drink to go along with the entire meal. There are 4 different appetizers, 5 different main courses, 7 different desserts, 3 different drinks. How many distinct meals can be had at this restaurant? Well, 4 different appetizers. So there are 4 choices for one appetizer. For each choice of the appetizer, there are 5 different main courses that's possible. For each choice of appetizer and main course, there are seven different desserts to choose from. For each choice of appetizer, main course and dessert, there are 3 different drinks to choose from. So in all, 4 times 5 times 7 times 3, 4,200 different meals are possible. Example 4. How many different bit strings of length 5 are there? Bit strings. Bit strings are just strings of numbers where only 2 numbers are allowed, 0 and 1. So I have a bit string of length 5, that is 1 position, 2nd position, 3rd position, 4th position and 5th position. Only 5 positions are allowed. Each position has 2 options. So 2 times 2 times 2 times 2 times 2 for each position. So that's 32 different strings. 5th example. How many social security numbers are possible? Social security number consists of 3 digits followed by 2 digits followed by 4 digits. Well, there are 10 different digits. So first position has 10 possibilities, second position has 10 possibilities, so on. There are 9 different positions. So 10 to the 9 different social security numbers are possible. Counting functions. How many functions are there from a set with m elements to a set with n elements? Well, here is a set with m elements. Here is a set with n elements. The first element has n options. Second element has the same n options. Third element has the same n options. In other words, we are looking at n options for the first element, n options for the second element, n options for the third element, so on, n option for the mth element. So n times all the way n, m different elements. So m to the power n number of possible functions are available to us. What about counting one-to-one functions? How many one-to-one functions are there? One-to-one is slightly different. Once the first element has chosen a location, second element cannot go to the same location. So second element has to avoid the position that the first element has taken. In other words, the first element has n possible images, but once assigned, the second element has only n minus 1 options because the one chosen by the first element cannot be taken. Once the first and second elements are chosen, the third element has only n minus 2 options, and so on. Therefore, there are n times n minus 1 times n minus 2 all the way n minus m plus 1 for the mth element. Possible one-to-one assignments. This already tells me n has to be greater than or equal to m minus 1. You see? Actually has to be greater than or equal to m. N has to be greater equals m. So the right hand side must be slightly, at least bigger than, at least as big as the left hand side for you to have one-to-one functions. Anyhow, so number of one-to-one functions are n times n minus 1 all the way until n minus m plus 1. Here is a nice telephone numbering plan. The North American numbering plan, NANP, specifies format of telephone numbers in the US, Canada, and many other parts of North America. Let X denote a digit that can take any value from 0 to 9. N digit denotes a digit that can take any of the values 2 to 9. How many different telephone numbers are possible if the telephone numbers have this format? N here, the rest are all X's. So notice N can be from 2 to 9, which means N has 8 options. X can go from 0 to 9, so X has 10 options. So N here tells me 8 and 8 options here. The rest of the locations have 10 options each. Multiplying all of these, I get 8 to the second power, 10 to the 8th power. All right. We'll continue the next exercise in our next video.